Okay, now we go back into the fair range presentations. And the next one is Andy Deel. Andy is going to talk about the I from interoperable.
Thank you. Actually, I think this is quite an interesting and challenging audience. I think some of you have got quite some technical expertise, and there's a lot of other diversity of skills and knowledge here. I am going to try and explain some basics and then delve into other areas, so I do hope that there's going to be something here for everyone. I've been asked to showcase Europeana as a case study for for interoperability. And I'll certainly do that, but I also want to evaluate the service against the FAIR principles, and then take a little bit of a look at what the future of interoperability might look like. Before I get into that though, I thought we should take a look at some photos of interoperability, because no Europeana presentation would be quite the same without a few photos from the collection. So what we've got here is we've got some railway tracks. This is a photo taken in France, I believe. And railways with conforming tracks and operational standards can, of course, share rail traffic. Trains from one country in Europe are most often interoperable with tracks from many other countries. If you fly frequently, you'll often, of course, cross an air bridge when connecting the terminal to the plane. And an aircraft is designed to be interoperable with airport facilities, such as air bridges or gates. A fire hose adapter is compatible with a fire hydrant. The last thing the fire department obviously would want is fire hydrants that come with all different types of sizes of connectors. They need to be interoperable, of course. And maybe you've marveled at the range of USB devices that you can plug into your computer and often have seamlessly just work. This, of course, can only happen because of interoperable standards. I once had a colleague who had a pair of USB-powered gloves, and he in winter used to come into the office and plug them into his laptop to keep his hands warm at work, all thanks to the marvels of interoperability. And then getting a little closer to our field of interest, we've got computer systems and the internet, of course, being the poster child of interoperability. Locally accessing information with, say, a browser that's held on a remote computer system requires many, many different types of interoperable data streams and standards with names and acronyms that most of us don't really need to know so much about. And lastly, here's a photo of a data table from Hungary in 1973. And I think it's showing the mineral content of water in a local spring. And I'm showing you this data table because I think it's an example of where there's low interoperability. To be interoperable is to have properties that allow for the unrestricted sharing of information between different systems. So as a piece of paper, yes, it's interoperable in the sense that it can be passed from person to person and read, but it has to be physically moved from place to place, copied if it's to be reused, and then, of course, the readers have to be familiar with the language. In contrast, if we wanted to talk about modern data tables, then in fact CSV is a really great acronym to know about. And most of you perhaps know that CSV stands for comma separated values. And while it's true that a CSV file could actually start out from an actual table of data like this, our normal experience is that CSVs are, they usually originate from some kind of data system. So what you're looking at here is data extracted from the Europeana data service. As you know, or many of you will know, Europeana brings together the collection records from all types of museums and libraries and archives across the cultural sector. Now in this case, I ran a query to find the first 100 audio resources which have a title, a creator, a media URL, and a date, all separated with a comma So here's a row of data, and that's a title, that's a creator, there's the URL, and there's the date. And I think this is a really good example of interoperability for the cultural sector, because our data, as often represented in our collection management systems, can often be extracted into this very simple data structure, which, once accessible, can be used in text files and spreadsheets and all manner of applications. At a very simplistic level, we can say that this CSV file has a few properties that allow for, I would say, the unrestricted sharing of its information. The file type is .csv. So you can see at the top of the window here, the file name is download.csv. And that's so that remote systems know what kind of file they're dealing with. And it's a common and well-supported file. And there are also some really clear data structure rules that can be easily learned by other systems. So, for example, each row of data ends with a new line. You can't see that new line character in the text editor, but it's there, and it's part of the rule set for comma-separated files. You've got the comma itself, which is understood to separate the field values from any given row of data, separating the title from the creator, for example. And I would say that a property of interoperability is that the rules can be understood. And lastly, the text characters themselves are represented in ASCII, which is the American Standard Code for Information Interchange. And that's so that different systems know that they're talking about the same digits and letters within the file. So there's this kind of shared knowledge representation, kind of like the agreement between a fire hydrant and a fire hose to use the same connector. And all this is by way of saying that I think CSV is designed to maximize the sharing of information between systems, or in this case, applications. And so as we move on to just explore the Europeana case study in this regard, I want you to keep an eye out for those properties that can make digital and cultural heritage more fair. And I know that many of you know Europeana, but just to remind ourselves what Europeana is all about. We're all about supporting cultural heritage institutions in their digital transformation. So ultimately, of course, we believe that we can transform the world through culture. It's a big mission. And so how does that actually break down for us? How does it actually work? Well, we've got about 3,700 cultural and heritage institutions across Europe now who share their collection records with us. And our combined catalogue totals about 58 million items. And just recently we've calculated that equates to about 2.5 billion individual metadata fields. And the combined catalogue is only possible because we've agreed some common technology and some common data standards. This is the first of our kind of three core pillars. We have a data standard called the Europeana Data Model, EDM, which many of you know about, of course. And simply put, if you want to include material in Europeana, you must transform your data into EDM or work with an aggregator who can do that for you. And the use of EDM here is one of the ways we enable interoperability. But it's not the only thing we do to encourage digital transformation. The second pillar is that we also have frameworks that encourage partners to improve the quality and their licensing practices. And when I say improve here, I guess I want to acknowledge a fairly biased position, because we believe that open and unrestricted access to quality informations like those in your collections makes the world a better place. So of course that's what we advocate for. And lastly, we have our public websites that make all of this collected material visible. I think most of us in this room probably take for granted that our institutions have digital copies of collection items available on the web, but in fact there are thousands of institutions across Europe who do not have substantive digital materials online. and we've really still got a long road ahead of us. The European website is not just a public tool for access, it's also a visible demonstration of digital transformation in our cultural sector. So can an institution get its material online and get it into Europeana? How good is the quality of its digitization? How mature is its approach to licensing? Do the collection records use vocabulary and enable multilingual access? All of these things we can see demonstrated in the Europeana website. If we're going to be talking about FAIR, we have to remember that the FAIR guiding principles for scientific data management and stewardship were intended to improve the infrastructure around scholarly data. This has already been mentioned today, but I do think it's reasonable for the cultural sector to see how well we're aligned with that. In Europeana's case, it's because we want more people to make use of collection material and data in academic research, especially in the humanities. And as I take you through the example, again, just remember to look for and think about what properties make digital cultural heritage fair. So if we're looking at Europeana just for a moment, here we feel that there's a really strong resonance between Europeana's principles of being usable, mutual, reliable, and fair, FAIR's own principles. Now this is largely connected to our principle of usability. And I think it's really interesting to just walk through these and see actually how Europeana stacks up. It's a great practical example, I think, and there's a few lessons that we can pick out from it. So findable. I'm going to come back to persistent identifiers, and Melanie set us up nicely for that, thank you. But the rest of it is looking pretty good. Yes, the digitized content that Europeana provides access to is described by metadata, and that of course is it provides the backbone of Europeana's services. But the scale and diversity of Europeana's metadata means that the richness varies greatly. Another way of saying that is some of the metadata is really patchy. It's also true that the Europeana data model supports the enrichment and linking of data to other semantic resources that add more context, and I'll be talking a little bit more about that in a moment as well. And this is where the usefulness of our publishing framework comes in, where we try and encourage good metadata practices so as to improve the richness. As mentioned earlier, we certainly do index the Europeana data set and make it available through our own searchable websites. In addition, the collected resources are findable through the European research infrastructures Clarin and UDART. So, when it comes to unique and persistent identifiers, both Europeana and our partners do promote persistent identification of both the cultural object and its metadata. A persistent identifier is added to every record, and from a technical perspective, we'd say that Europeana identifiers are URIs and are included in the data records of all the formats in which the data is available. But here's the thing. It's about the context of aggregation. So where data is passed and processed by different partners, we cannot, and actually for provenance concerns, we don't want to enforce global uniqueness. This means that there can be several identifiers for several versions of a resource. But we do try to maintain links across all these versions so that users of our services can always find what they're looking for. Looking at accessible, yes, Europeana identifiers are resolvable. They're HTTP web addresses which connect users and services to pages on our websites and to data from our APIs. And our collected record data is accessible through an API, and that API implements open standard protocols like the linked data protocols, OpenSearch and OAI-PMH. I think an interesting demonstration of this accessibility is actually related to the CSV file example we were looking at earlier. One of the access protocols we support is Sparkle. And this is what you're seeing on the screen here is the query that I ran earlier to create that CSV file of 100 audio records. And here's the neat thing that, as a researcher, I can then choose many other file formats for this data. So if I'm doing computational research in the humanities, this is incredibly powerful because now the cultural data is more interoperable with the different types of software that I might be using. Access to the collected records on the Europeana website via their web address is free. No login is required. However, some of the APIs and parts of our platform do require login if they allow modification of the data. I think the principle that the metadata is accessible when the data or the object is no longer available is a bit challenging for us. And it's got a question mark because we're supposed to remove the record if there's a broken link or if the institution removes the item. And perhaps this is a case where our situation is a little different as an aggregator. So we've actually already covered a reasonable amount of ground on interoperability already, but just to summarize, we can again say yes, we have a formal, accessible, shared and broadly applicable language for knowledge representation, and that's the Europeana data model. And here is what one part of it might look like. And I know this will look maybe a bit technical for some and maybe a bit simplistic for others, but I want to walk you through it because this is at the core of interoperability. So EDM is based on the Resource Description Framework, RDF, which allows us to create a model for our metadata that mostly reuses existing linked data and standard vocabularies like Dublin Core, SCOS, and FOF. And in this case, you can see a representation of a dramatic production, which is a nice tie-in to the lightning talks. In the middle, called Leonce Underlina. So the provided CHO is the cultural heritage object which has given rise to the metadata. And this production actually identifies George Buchner as the creator using DC Create, and that George is an actual person through the use of FOF, friend of a friend. And next to him we can see that Gustav Lindemann has been designated as the director with the ECLAP prefix. Hope you can all see that. Yep. So ECLAP is the European Collected Library of Artistic Performance, and they have their own semantic data model similar to EDM. And then we can therefore connect to it to get more precise definitions of this type of work. And this, in a nutshell, is what semantic interoperability looks like in practice. It's a set of connections that tells us how the metadata can be understood across domains. Here's another example of semantic interoperability, where in the top bubble, we have a cultural heritage object that has a DC title, DC creator, DC description. But there's also a DC type, where we use the Simple Knowledge Organization System, SCOS, to specify what type of thing this is. So in English, we can see that we specify that this thing is a harpsichord. And you might also see that there are different language variations also. So when you're thinking about your own data, and you're thinking about FAIR, think about how connected it is. Does it exist in an information silo, or is it interoperable with this kind of web of data? Vocabularies are really important in the same way that ASCII text was important for the CSV file. They help us to be certain that we're talking about the same thing, not just about or across collections, so that we know all about the harpsichords, but also across languages, because of course metadata will be recorded differently based on the location. The most prominent vocabulary we use within the collected records are from DBpedia, which has got a really very rich source of multilingual terms taken from Wikipedia. And we also use geonames, which we use for place names. And finally, yes, the Europeana data can include references to other records. It depends, of course, on what context data is provided by the institutions themselves, or what enrichment can take place to support this. The best example I can provide, I think, of that is the case of the new collection pages we'll shortly be releasing on the Europeana website. So what you're seeing here is someone following a path to a Vermeer collection page, through to the painting collection, and then onward to the Peter Paul Rubin collection. And they're following a linked data path. And we can only enable these kinds of connections when metadata from partners includes all the right contextual information. So, where does that leave us in terms of the properties of interoperability for digital cultural heritage? So this is my take, and it's my take if we want to maximize the sharing of information between different systems. Data needs to be available and understood, not just online, but in a structured data format like EDM. Data is extended with context to maximize usability. Vocabularies are used to represent knowledge in a common way. The data is translatable so that understanding can occur across cultures. And data is linked to other related data sets to maximize the ability to follow connections. Just to round off the FAIR model before moving on to the future, I just want to cover off reusability quickly as well, because facilitating reuse is a key part of the Europeana objective. Any metadata provided to Europeana needs to be licensed under CC0. And Europeana makes the complete aggregated metadata set available, including any changes which we make, also available under CC0. And the rights for using the objects are stated in every record using right statements from either Creative Commons or rightstatements.org. The provenance of the data is always stated, acknowledging the original data provider, like a museum or a library, and all the intermediaries in the aggregation workflow as well. The reason we have a question mark over the core principle here is because of the requirement for accuracy. Europeana has a great model for reusability, but of course the data is only as good as the data that comes from the institutions. And as you may know, there is actually quite a lot of work we also need to do in that space. Covered quite a bit of ground here, but hopefully just by exploring interoperability for Europeana and its relationship with the FAIR principles, you've got some more ideas about how this might be applicable to your case. For this last part of the talk, I just want to turn my attention to the future, and just to be clear, this is speculative. I think nobody really knows how things are going to evolve, but I do think it's interesting to reflect on some of the things that are happening and consider what they might mean. And so I've been thinking about some of the properties of interoperability in the future. First up, I wonder if we might see intelligent artifacts that encapsulate their own context. So what I mean by this is that currently we separate the collection item, the object, the work, the artifact, from its metadata. So let's say you've got a digital image in a repository, and then in an entirely different system, you might have a catalogue or an archival record with your metadata. That's how it's often been. I wonder about what would happen if that were to change. What if the metadata effectively travelled with the digital object? And more than that, what if there was some intelligence that went with it? The clearest example I can give of this is rights information. If someone were to download a photograph that encapsulated its own context, then the object itself might be able to reject or support any action that you wanted to take. It might be happy to be embedded into a blog post or be shared on social media, but reject any editing within a photo editor. Interoperability of data would therefore become a property of the object and not be separated from it. I think this is possible. The second property is that cultural heritage objects could be part of a self-connecting network. At the moment, in order to create relationships between items, we need to make sure that the correct metadata terms are included in the record. For example, the example we talked about with adding the SCOS labeled harpsichord. That needs to be added so that we know that it's a harpsichord. And up until now, most of that work has been done manually. But there are some of you that have been, I'm sure, experimenting with machine learning and automated classification systems. These are mostly efforts operating on silos of data. And it's not unreasonable to think that if objects do start to encapsulate their own context, then they'll be able to propose relationships, connections with each other. So one Vermeer digital object might come in contact with another Vermeer digital object and infer some connection based on statistical similarities or differences. I think a self-connecting network could provide additional support for interoperability. Thirdly, being multilingual by default means that the tools we use to generate metadata would enforce multilingual interoperability. If we truly want to support unrestricted sharing of information, we have to deal with language support up front. And lastly, non-consumptive availability. I'm not sure if this is widely understood, this concept in the GLAM sector, but this property refers to the ability to query an item without providing access to the item itself. An example might be allowing a researcher to do text analysis of a book in copyright without giving them access to the full text, or the ability to research perhaps historical government archives without providing access to the classified materials themselves. Or Bridget mentioned another perfect case study where you might need to maintain support for customary law. We can recognize that even as we keep pushing for open access, there will still be legitimate reasons why that won't always be possible. And so the question is whether non-consumptive availability can help extend access and interoperability in the future. Some of these ideas might sound a little far-fetched, but I think in this case they may not be as far-fetched as you may think. For example, in July of this year, the New York Times announced a research project to explore ways to better make the origins of journalistic content clearer. This is part of the efforts to fight fake news. Their first project is to explore how adding context to images might support that. In this case, they're proposing a blockchain model to make sure authoritative data is always connected to the object. And this is getting closer to the idea of encapsulating the data with the object. Interestingly, blockchain is also able to support that kind of intelligence that I was speaking of earlier. Earlier this year, we also saw Amazon Web Services launch their own open data program. I think this has been a little bit under the radar in the GLAMS sector. I haven't heard too many people talking about this. But what they're looking to do is cover the cost of storage for publicly available cloud data. And among their goals is to work with data providers who want to develop new cloud techniques and formats and tools that lower the cost of working with the data. And I think this is really intriguing because if a self-connecting network is to develop for the cultural sector, where data points may start to infer their own relationships, then I think the techniques and tools are more likely to come from the commercial sector first. And that's not to say that that's where we want it to stay, but it might give us a little bit of a push. Perhaps evolving from an effort like this where you've got this evolving concentration of open data on one of the world's top artificial intelligence cloud platforms. I wonder if it's going to create the conditions for some significant innovation that might then cross to the cultural sector. Last month, I was very pleased to help organise and host an event under Finland's EU presidency. And the topic was multilingualism for digital culture and heritage. And we had about 40 experts and policy representatives from across the member states. And this is one of the outputs from that event. And what you're looking at here is the issue and solution options for multilingual support. Mapped across, so on the vertical axis here we've got capabilities. On the horizontal axis we've got technology availability. And what we saw was this concentration of issue solution points in this bottom right quadrant, meaning that we saw that for many cases the technology is available to make our collections truly multilingual, but what the sector at large is lacking is the capability for action. Capability in this case referring to the knowledge of our staff, time and not surprisingly funding. Point here is though that true multilingual interoperable is actually solvable right now. And lastly, if you've heard of non-consumptive research before, then you've probably also heard of the Hearty Trust. So this is a service that they already run, interoperability with secured and private collections where you don't actually get access to the items themselves is already happening. The better question is perhaps whether you will see, or we will see, its usage growth in the future. So just in closing, I can offer these final thoughts on how you can best prepare yourself for a future of even greater interoperability. So look, again, I mean, you've heard this many times today, but make your data available and make it understood using some structure. And not just some of it, all of it. Before moving to Europeana, I spent a decade at the National Library of New Zealand. We hold far, far more data than we make public. We should be making much more of our data available. We need to build in technical flexibility. If you're locked into a technology vendor that's not moving, or you feel you're not in control of your technology choices, then you need to try and change that. And I appreciate that that's not easy, particularly for small organizations, but it's just a reality that if you want to take advantage of these opportunities, you have to keep up with the evolution of the technology. Invest in staff capability. It's an obvious point, but we all need to take the time to keep learning, and it's hard keeping up, but it's just what we have to do. And lastly, share any multilingual data that you have. While it's true that the technology largely exists for multilingual interoperability, the systems need more training data, particularly for cultural data within historical time periods. So that's it. There's a lot more I have to say on all of this stuff, but hopefully I've given you something to think about. Sadly, I'm not available to stay for the Q&A, so I'm told that we've got a few moments for questions now, and I'll be around at the break afterwards. But thank you.
Now we come to the fourth and final letter of the FAIR principles, reusability. And our next speaker is Joe Petfield, lead conservation scientist at the National Gallery in London. And Joe is going to show us examples of the reuse of data in National Gallery projects and in National Gallery related projects. Joe?
Good afternoon. As said, I'm going to try and talk to you now about the final letter R, reusable. Basically, what I'm going to try and do is very briefly bring up the FAIR principles and concentrate on the reusable ones. They have been seen a number of times before. And then I'm going to talk a little bit about traditional reuse, comment on the problem of closed data, which maybe not is accessible, touch on the notion of who data should be accessible for, the question of computers versus people, and then a number of examples about making FAIR data, and then sort of commenting on some potential people who might use our FAIR data. Now, there's quite a lot in some of these slides that I'm going to show, and because they're going to be available afterwards, you don't necessarily need to take every bit of information that's in the slide in. They're just being used as examples as I'm going through. So begin with reusable. So we've seen this wonderful diagram before, which I quite liked, and I've made a slight adjustment to make the reusable a different color there. So what we have here are for the details of reusable. We're looking at the metadata is quite important, as it's been discussed a lot today, and ensuring that it's accurate and relevant to the digital objects that we're exploring. We want it to be a clear and accessible data license. This is probably one of the most important ones for reuse, is that if people don't know what they can do with it, people tend to go off and find some other data they can explore with, because no one's going to invest time in exploring data sets if they then find out they can't actually use or publish the results of their work afterwards. Provenance is very important, looking at the trust, looking at whether you can base your efforts on it, whether you can actually do work from there. and domain relevant standards. So does it connect and make? So we've already had interoperability and accessibility. So the standards allow you to be able to connect your work and connect one source of data to other things so you can reuse it. Now, in previous years, DARIA EU, one of these wonderful acronyms, which is Digital Research in Arts and Humanities, I think. The DARIA EU group, which is a permanent EU infrastructure, looked at creating a data reuse charter. And this was to try and extend the FAIR sort of initial 4 principles and say that within digital humanities, we also need to look at reciprocity. So the issue of what we might do with our data versus what the user might do with the data, and then whether we're actually having a conversation or whether it's just disappearing and we never find out. Because the goal of linked data and interoperability is that the people offering data also benefit from the work that's done by the people using the data. So reciprocity is quite interesting. They pushed interoperability as well, which was already in there. The notion of citability, to ensure that people actually get recognition for the work that's being done, was quite important. And openness and stewardship and trustworthiness. So they were just underlying some of the ideas that came across within the FAIR principles and just saying that these are actually really important. We need to sort of look at them. So there's a link there to the actual charter that they've produced. It's quite interesting. So, traditional reuse. We in museums and galleries and libraries and archives have been reusing data for a very long time. So as long as libraries existed, people went in, got a book out, read the book, used it for research. So the data is being reused and has been reused. So within museums and galleries, we're looking at publications, exhibitions, research underpinning conservation treatments, or ongoing further research. This is quite a common thing that we all do. The situation just got a bit complicated when these annoying technical people gave us the ability to start digitizing things. And then people look at, well, it's digital now, we can do so much more, but no one actually gave us any more time, which is generally the tricky bit. So we can then do more. But research reuse has actually been formalized quite nicely over the last 15 to 20 years in a process called ArcLab. Now, ArcLab initiated in a project called Charisma, which was an EU framework project in 2009. And the idea is that there's EU money for you to say, I have a question of the information that's in the Rijksmuseum archive, if they are offering an ArcLab option. I would like to go and study with them for a week and ask their specialists lots of nice questions about their data and look in their folders and files. And the EU says, yep, here you are, that's a very nice bunch of cash, give it a go. So within Charisma, and then following on to the Hyperion CH project, which has just come to an end, effectively we built a proposal process where people would have a research idea, they could see what ARC labs were available for them to go and visit, and then they would put in a proposal, the proposal would be explored and addressed, and people would then able to go. So the National Galleries provided access to our samples, our photographs, all of the information we have. A lot of it is analog, a lot of it is now digital. It's just not accessible outside of the building. So just as an example here, this was one particular project that people did, exploring Giovanni Bellini's work. So they came and looked at the x-rays and the samples we had to actually do new research that created new publications and new outputs from them. That's ArcLab. It's continuing. So ArcLab is going to continue in Hyperion HS. Just to give you an idea, the CH is cultural heritage and the HS is heritage science. So it's expanding to include paleontology and archaeology. So that's beginning next year. And there's the notion of ERIS, which I'll come back to later, which officially is going to begin a few years afterwards. So there is also existing collaborative reuse, but it's not really fair. So to give you an idea, the ones on the right are easier. These are large sort of aggregators of data, and Europeana, which I didn't put in because various people have been talking about Europeana as another example, is we have the Google Arts and Culture. You can go to the National Gallery page and they have information about our collection. However, there's no connection between their collection information and our collection information. So if we change a title or change a date, it's not propagated up. So there's no actual connection. So someone actually spent a lot of time, prepared a large Excel spreadsheet and has posted it to Google. And this is the same with the Art UK project below. So they have a collection of the whole 180,000, I think, paintings in UK public collections. But they don't have any connections back to the institutions. The two examples on the left, the Raphael Research Resource is one I built in 2007. The project started. It was to provide a platform which contained conservation, archaeological provenance, copies, drawings, scientific data, conservation data, basically every single piece of information we could get our hands on, including sort of photographs of original source material. And myself and an art historian worked on this for a few years, and she got to travel around the world visiting archives and photographing documents. And I built this sort of structure. It still works, but it's locked, it's closed. You can't really put any more data into it now because I haven't had a chance to update the code to allow you to do that. So it's something that you can look at it, you can explore the website, but it's not as fair as it could be. The grounds database in the bottom left-hand corner is one we've just built. And it's a collaborative effort to explore the trends and usage of paintings priming. So when you paint a canvas or a panel, and the color of the priming, the materials that are used, the number of layers. So people are sharing scientific data and art historical data to be able to produce a resource that this can be researched in. So it's going to be open, it's going to be accessible, but it's not really fair. So, closed projects. This I wanted to put in simply because it came up as a discussion last week back home. In 2011, there was a project collaboration between the National Gallery and the Wallace Collection looking at the technical examination of 12 paintings by Sir Joshua Reynolds. And for those of you who don't know, Sir Joshua Reynolds very helpfully mixed lots of strange things into his paintings. So if you are nicely trying to remove a discolored varnish and you find out that the painting layer is also made of varnish, that could be quite problematic. So they wanted to do a detailed study of these before actually touching them, okay? Now, the thing is that some people were working in the Wallace and some people were working in the National Gallery, and there was an international advisory board. So how do you document that realistically? So in the end, we used MediaWiki. So it's the software that runs Wikipedia. So we set up a new one, we gave them all logins, and they allowed them to give it a go. Now, effectively in there, we had pages for paintings, we had pages to discuss surface coatings, we had pages to discuss details and x-rays and infrareds. We even had lovely categorizations in the top left-hand corner of noses. And how many people can spot the dog's nose in the right now? Just further in there. But it gave you the functionality to actually then to start doing their work. Now, from a technical standpoint, I took that a lot further and started playing with semantics and sort of how you would then export data and the interoperability issues of how that would flow, which is published in an ICOM CC paper. The actual conservation work and the art historical work which came out of it were published in one of the National Gallery technical bulletins. So the publications are findable and they're open access, so they're relatively reusable for humans, but the data itself is closed. And the original resource data is not fair because it was never planned to be an open repository. So no one actually had the discussion about what the license would be or who had to say yes or who had to say no to which data would be available. So it's sitting there, we're maintaining it, and I know my colleagues are using it, and some other colleagues from the Wallace still use it, but we haven't been allowed to open it up yet. And principally, as several key members of staff no longer still work in the Wallace collection, so we can't actually know who can say yes. So we're still ongoing, trying to have this discussion, but at the moment, it's not that fair. So who or what should our data be fair for? Okay, so here's a question. The fair data, if you start looking at them, and talking about interoperability and file formats, and we want the CSV, which was very nicely explained before, and looking at standards, it's kind of for how do computers talk to each other. But actually none of us, I'm thinking, none of us are computers, we're all humans. So there are two levels of things here, is if you're looking at, is data findable? Well, if I type it into Google and it pops up, then it's findable. The computer might not be able to do that because they haven't explained the context of what we're trying to do. What FAIR does is it forces us to actually think about what we know and what we assume and describe that in a manner that's reproducible. So we do need to consider this. We need to think about the documentation of anything we do. It needs to be work for computers or technical people, and it needs to work for the practical people who are doing the job. So it's always a difficulty there. Because you can provide a downloadable file. Here's my data set, click, boom. But you can go all the way to very nice APIs with standardized querying languages and have searchable interactions. There's a whole range of things that you can do to make your data reusable. This is the Raphael Research Resource. So as I said, it's a web interface, and down the left-hand side you can sort of see, oh yes, pointer, all the different types of information that was down there. And that's the web address. And it does actually work. And for something that was built in 2007, I'm quite pleased it still works most of the time. That one was designed for humans. But this one is designed for computers. So all of the data that, apart from the images from the Vatican, because we're not allowed to share them outside of the building, all of the data that's in the Raphael Research Resource, including the image paths to build potentially IIIF compliant imagery, is all available as a large XML document that you can download. But it's also installed in BlazeGraph, so you can run Sparkle queries against it. And there are examples of how you would get painting information, how you get image information, how you might build an image viewer. So this is kind of a cross between. It works with computers, but it actually explains and provides examples so that humans can reuse it. So we use it as a test case, and I'll come back to this in a second. Here we have 3 representations of exactly the same data. This is the National Gallery webpage for Room 30. This is a JSON dump of information describing Room 30 from one of our computer systems. And this is an early CDOC-CRM description of the same data. So we can have multiple formats, and that was actually shown in one of the examples before, that they had 4 different viewers for exactly the same images. We can have multiple formats and multiple presentations of the same data once we have some form of structure. So making data fair. So here's a few examples of this. Now this is a hideous diagram. And I do apologize for that. It's become more and more complicated over time. And effectively, we're trying to describe what a local repository needs for data. So not the software, but effectively the bits. And when I make the paper sort of available, you can look at this diagram in more detail. But to make it slightly easier, we'll do this instead. So effectively, what we have here is we have storage. So digital and analog storage. We have folders, files, computers, databases, and things. And then effectively, we have a bunch of processes that create data, that examine data, that provide services based on data, licensing, and these sorts of things. And these might be done in-house. They may be done by an external company or external service. We have a presentation layer, ideally. So something that aggregates all of the available information together. So if you, as an internal user, can just make use of any of the data that's available, okay? And then on top of that, you build your websites, your digital documentation systems, your image data viewers, collaboration tools. That's what you use. So that's effectively how middleware works. And then, if you've got an okay from your executive board or director, that's lovely having your director just say that everything has to be free. That would make life an awful lot easier. You then have an external presentation layer, which has probably a limited version of that data for other people to use. So big EU projects, Parthenos was mentioned before. There's quite a lot of these projects out there that want to explore the use of data, even if it's just testing a generic idea, but there's lots of people who actually want to use the data, the content itself to study. But then that allows other people to create websites and viewers and collaboration tools and so on and so forth. So this is the plan of the model, and that sort of includes a lot of the modules for it, or the bits of it, and it's an ongoing thing. So I think this particular version is version 2.4 of this model that I built, and it's evolving over time. And this is eventually going to be used within the ERIS project, which I said I'll come back to in a second. Now, very nicely, Belgium is testing this for us. So there's a project they have within Belgium, centered in Kikkerpe, called the Heskida project. And what they're looking to do is to develop a repository for heritage science data archive. That's basically what Heskida stands for. So they want to be able to answer these types of questions. So they want to gather all of the data they have together, similar to what was planned within the Raphael Research Resource I mentioned before, but using modern sort of technologies, proper data repositories, proper standards, using a lot of the correct processes. And they've received a fairly sizable grant from the Belgian Science Policy to do this. So effectively, we're working with them to allow them to test the ideas we have on for a European or global level. They're testing it for Belgium to see if it'll work, which is extremely nice. And they've been doing some really nice work, and that'll be coming out quite soon to see what they've been doing. Their website is under construction. It keeps on breaking, and there's not an awful lot of content there. I mean, you're welcome to have a little look, but I tested it before I came. Here's another example of data. The National Gallery now has an official API, but it's not properly documented like the one that was mentioned for the Rijksmuseum. This is an old one that I made a number of years ago, and effectively it's a public face of a hack, shall we say, that combines a lot of data sources within the gallery. So you can look at information about our objects, information about artists, information about titles. We have 36 paintings that are portrait of a man. So the titles get reused. I mean, there's an interesting discussion all the way through today about PIDs. Effectively, you really want a PID for anything you might want to argue about. So we gave PIDs to titles, to room numbers, to objects, to artists, to keywords. Basically anything we wanted to hang any property off, you give it a PID. And just don't care about it, just give it a PID. So you can, this is live, you can play with it. If you remove the /resource at the end, you get the new one, which is coming from an Elasticsearch output, which is going to be the new structure, but it gives you a lot more data, but really isn't documented too well, so it's a bit unclear at this time. We also set up a IIIF one, and I will warn you, the images are quite small. But we were looking at the structure of how we provide a resource to allow people to explore the entire collection and a small IIIF image of anyone. I've looked at a lot of websites and you search the collection and you find the little IIIF logo and you can then use them. But the idea behind this was to try and group them together. So I want all of the images for room 30. I want all of the images for this artist. I want all of the images that have got castles in them. So effectively it produces the manifests or the grouping lists of IIIF images. It produces it on the fly for you based on what you search for. So this is something we're hoping to explore with a lot more. Now, it's been mentioned before that a lot of use cases are actually internal. So this is an internal example. Now, the art lab that I mentioned before is physical. People turn up and they have to know what's in a collection and know what's in a repository to be able to put in a proposal and explore. So what we'd like to do is to try and say, well, how can we make that easier? How can we provide direct access to appropriate digital resources so people can put together better proposals and know what types of questions they can ask of a collection? So one of the first things we'd like to do is to publish inventories of the scientific archive, to be able to say what's happened to paintings and what techniques have been used. And as beginning of that, we've actually used Mirador, which is one of the IIIF viewers that have been expressed there, to gather together all of the information we have from the various different departments to allow a digital sampling point system. So effectively, people can put a little spot. We took a sample from here. There's a picture of the sample, which comes from the digital asset management system automatically. We can describe why we did it, who took it, when was it taken, what happened to it afterwards, and then link it to the documentation afterwards. But what I've also added in there is this little button which you can't read, and it actually says J Drive, and it's effectively the place where the scientific department sticks all of its reports and data outputs. It's just a Windows drive, and it's just called J. And effectively, if you click that button, little software goes off and says, ooh, I know that GCMS data is a certain file format, and it's in these folders. Are there any GCMS files for that painting? And it basically builds you a report to say which techniques have been used against which objects. And it's live each time you push it. So effectively, at the moment, that's not linked data, but we can add that to the external API. So people would say, well, which ones have been analyzed with GCMS? Which ones have been analyzed with XRF? At the moment, it's a bit of a test, so some of them say 0, and they shouldn't do. But this is what we're working on at the moment, to actually allow people to know what data we might have in the archive to explore. We want to make it more findable. This is a small experiment I'm doing with the CDOC CRM. Basically, a lot of ontologies are done based on theory, and you find a lot of publications looking at theory of how you would actually do it, and then you try and do it in practice, and you've no idea where to put the data. So where do I put the title? Where do I put the fact it's 215 centimeters wide? So this is a presentation of an example of how you would describe this painting. And the red boxes actually have the actual data in it. So you've got a description, you've got a number, you've got a title, you've got the actual data. And it was done in the Hyperion CH project. And there's a document, a deliverable, that's now publicly accessible for that. What I'm going to try and do is on this website here, and this is, again, work in progress, is make it so you can actually pull them apart and explore. So this is quite a dynamic presentation. So you can drag things around, and you can also put more documentation on each of the nodes and explain what it is that's going on. But the purpose of it is actually for people to tell me what I got wrong. The thing about ontologies is that everyone thinks about them slightly differently, and the only way you can build a consensus is that if you have enough examples. So that's kind of what it's for. This is another one that we're going to be doing quite soon. So the Social Science Humanities Open Cloud Project, or SHOC, is an infrastructure project of infrastructure projects. So if you take projects that have got 20 or 30 members, and then you get a room of them, so you've got, it's a political insanity, but it's really good fun. They're doing lots of really nice generic work on data, looking at things like dataverse repositories, or looking at protocols, or how you connect data together. It's a very nice one to look at. The National Gallery has one small task in it, which makes life slightly easier. We're going to take the data that I mentioned in the Raphael Research Resource, and take the data that we've prepared in the grounds database, and we're going to make sure that it's fair. So we're going to spend 9 months next year, beginning in April, and make accessible, fair data sets of these two sources, using a standard ontology, linked open data vocabularies, probably using Wikidata as well, and using IIIF, as both of them contain an awful lot of images, so that it's a fair resource. One of the main reasons is that, A, this one's a bit static, and we want to make it better. This one, the searching's a bit slow and a bit fiddly, so we want to improve the searching and give a lot more flexibility. So we're going to try, he says with his fingers crossed, exploring a piece of software called Research Space to do this. Research Space was funded by the Andrew W. Mellon Foundation to produce a platform for exploring semantic data and arguing about it. It includes IIIF, it includes the CDOC CRM, it allows you to record belief. So you can say, this is my evidence, and that's your evidence, let's have an argue about it. So that's what we're going to try and use. And it was funded by Mellon to provide a proper platform for the projects that the Raphael Research Resource was one of. They funded 5 at the time. But you also create software to do things. So what I wanted to say is that we're trying to make the software available as well. So within the Hyperion project, we built a little widget for a free open source piece of imaging software called NIP, so that you could calculate the average color of a non-regular shape. So particularly for cross sections, you can see these are the multiple layers in a painting, with the ground layer, the preparations, and paint layers. If someone wanted to know what the average color of that was, it gets a little tricky drawing a box to make sure you've got everything and not bits you shouldn't have. So we built this way of, you just put lots of dots around them, you can move them around, and it'll output you the color. And this software is now available on GitHub, and you can download it and add it in with a number of other widgets we built. There's one that I built that's actually extremely useful for changing the colors of logos. If you've got a 2-colored logo and you're sticking it in your presentation and it doesn't it clashes too badly, it just basically works out what the 2 colors are and you can swap them, which breaks a lot of guidelines for using the logos, but sometimes it's useful. I've been doing it on my own logos. So the other thing, it's incredibly useful for doing other data. We found that if you want to color black and white images for effect, it works the same way. So you can look at it, gets the black and the white, you replace one of them with green, and it gives you different presentations. So it's quite useful. The digital sampling point system I used, it's not there yet, but we're trying to make it sort of extract it from the various National Gallery systems. So that's going to be available here. And I found that SAOI is actually an Irish word for wise man or something, which I didn't know before I came up with it, so that's wonderful. The CDOC CRM examples that I showed the big model in, we're going to put each of the individual ones basically up on GitHub as well, so people can put up issues and argue about them. GitHub is designed for software development, but you can actually use it for other things as well. It's idea development, and it's a nice platform. Because I know there's lots of errors, and I actually got an email today pointing out some of the errors, so we can actually start having discussions about those models, which will be really good. So who will use our data? And I'm running out of time now, so being nice and quick. CrossCult was another EU project we were in that's come to an end now. It was really good fun, and it did a lot more than just what I'm going to say. I would recommend looking at. One of the deliverables was 280 pages. And the reviewer said, I really liked the deliverable. I read it all. It was really great. But I should tell you that 40 of the pages are direct copies of other 40. So someone had combining files together, and they copy and pasted, and then it should have been 240 pages rather than 280. But they still read them all and really liked the deliverable. So that was quite good. But effectively, for the National Gallery, what we did is we took those two APIs that I showed you that were generated within the Hyperion project, so the basic tombstone data and the rooms and the locations and the images, and we created a mobile app for the National Gallery. So each morning when it gets updated, the paintings move around. They don't stay on the wall. They're very annoying. So they move around. So what the app does is it tells you where you are, where the painting you're interested in, and shows you how to get there. If you tell it you've got half an hour and you're interested in Impressionism, it'll say, well, go and look at these 5 paintings. Go and have a plan. This is where they are. This is the route you can take. It's got some very nice functionality in it, thoroughly beta, and we're currently looking at how we might sustain and move things forward. But that was a very nice use case of building the API in the first place. So that was used by a number of different institutions who were involved in that project. There are a number, so I think this one was mentioned as a possible source earlier for the creation of those works of art that were shown earlier. It's the Lucas Cranach project. The Raphael Research Resource, as I said, was part of a few. The Rembrandt database was one of the original 5 that were funded by Mellon. These projects contain information from the National Gallery paintings, but again, there's no connection. So when we change and update, so basically we can look at providing dynamic access to these research resources. The 2 others that I mentioned, we're in current discussion with Art UK and Google on how they will be able to use our new API, and we won't need to prepare new refreshes each time we change a title or something. So that works in the promise at the moment. And just to finish with, this is ERIS. Now, I mentioned that ArcLab began in Charisma in 2009. The journey actually began 20-odd years ago, almost. And effectively, the plan that's followed through all of these projects, that started with EU Artec and went into, it was LabsTech, EU Artec, Charisma, Hyperion CH, Hyperion HS, and then ERIS. It's been a long journey, and it's all about access. So ArcLab, as I said, provides access to archives. FixLab, you can take your sample to a nuclear reactor or a large synchrotron, and they will analyze it for you and give you a large amount of data. MoLab is really fun. They'll turn up in a transit van with every piece of mobile data, mobile analytical equipment they can get their hands on, and analyze your equipment, again, based on peer-reviewed research. Now, DigiLab is going to be the new one. So DigiLab doesn't exist yet. That's what that local repository model is part of. We're planning what will be needed in DigiLab. And the notion is we want to try and gather together as much of this information. Now, as you've seen today, lots of people are doing this work. DigiLab's not going to recreate all of this. There are digital registries out there to create PIDs. We don't necessarily need a new one. We just be able to tell people in the heritage science community which ones you can use. So you want a PID for a book, go talk to these people. If you want a PID for a painting, go talk to these people. Data repositories, there are lots of them out there. Again, we won't necessarily need our own. But we've just been identifying which bits are going to be required to create this kind of platform. And primarily looking again, because ERIS is based on access, is access to virtual research environments, to data sets, to the repositories. Access to physical services. So someone might be able to turn up with a laptop and install IIIF server in your community, in your sort of systems, and show you how to do it. A GitLab. We have set up a GitHub that I've mentioned before is a public open software development service, but you can use software like GitLab to have it slightly more closed through development. And just community and knowledge and understanding. And this is an ongoing thing that we're building. As I said, DigiLab doesn't exist at the moment. We are constructing it as we speak. But annoyingly enough, ERIS stands for the European Research Infrastructure for Heritage Science. There's already 2 nodes in America, there's a node in South America, and I think there's one in China. So it's kind of going global before we've even managed to get the European one up and running. But at the moment, there's hundreds of different institutions involved. It's going to be an absolute monster. So to sum up, when you're looking at reuse, consider potential reuse early, while all of the staff are still there. Okay? It's very hard to have the conversation when they've gone. Capture all of the required metadata as you work. Going back and doing it again the year after is a huge amount of work and you never have time for it. Ensure all of the relevant work is fully attributed. Who did the work? Who did the effort? Make sure they get the credit for it. Document and format data for generic reuse. If this can be done as you're going along, again, it saves time. But you also might want to think of who your target users are. I mean, people talk about make your data fair, make it available, but actually, if you're targeting art historians, you might want to go and talk to the art historians and work out what formats they want to see your data in. Actually, we don't worry about all the numbers, we want to see the images, and we want to have the provenance. And agree on a license for potential reuse as they're created rather than years later. Thank you.
Now it's time for our final speaker. And next up is Irma Hermans from the Rijksmuseum. She is Rijksmuseum Professor of Studio Practice and Technical Art History at the University of Amsterdam and the Rijksmuseum. Irma is going to show us how open research data works in interdisciplinary research.
Thank you very much for the invite to speak here. I have a confession to make. I'm not a data scientist. I only use the data that are collected by all of you and your repositories and your databases. And sometimes that leads to very unexpected confrontations. So I'm going to talk a little bit about the research we're doing here at the museum and how these databases come into play. And so it's quite a different talk than the rest of the day. But I've already heard so many things, especially from Joe, that are fantastic for the kind of work I do. So I'm a technical art historian. Which means that I look at artworks from a material point of view and really how they were made. The act of making is very important to study in that respect. And this morning somebody asked about, from the V&A, about how objects change over time. And we actually study objects. This is my title slide. We study objects in very different ways, combining art historical with very technical analytical work, but also the context in which they were made, the context of the materials, all these things come into play. And that leads to intersecting narratives, as we call it, between all these different approaches, a material history, but together this all forms the object biography. So how does the object change over time? How was it made? So from the beginning to what we see now. All these things are very important to address. And if you want to put that all in a repository, that is a very difficult thing indeed. And so I appreciate the question that was there this morning. It's the rapidly developing application of scientific analysis, especially over the last decade, has the potential to offer novel insights into art production, but it also places very complex demands on the arts and humanities to provide these narratives, in other words, the interpretation of such data, which requires very strong interdisciplinary communication and collaboration. This holistic approach to refit such analysis and feed their material and contextual interpretation into object biographies will be transformative for the way art history studies our cultural heritage and presents it to the public, and will also impact on notions of authenticity and artistic intent, as well as longevity and preservation. The increase in digital documentation methods, 2D, 3D, scanning, digital imaging, supported by data science to develop new applications as well as research tools for big data sets, adds another piece of kit to that toolbox. Generating digital output and providing open access will enable close collaborations between researchers from different disciplines, crossing traditional boundaries, and hugely impact the ways information is shared with both specialists and non-specialists alike. And I have to say that when I started as a technical art historian, I worked mainly on case studies on one object. But now, with so many data being available and open access, we look much more in comparative studies, and it has opened up and transformed the way we examine our cultural heritage at the moment. This is extending more and more, and just wanted to show one database that is being made, which I particularly very much like, and that is the Endangered Archives program from the British Library. And the co-founder says the Endangered Archives program captures forgotten and still not written histories, often suppressed or marginalized. It gives voice to the voiceless. It opens a dialogue with global humanity's multiple past. It's a library of history still waiting to be written. I think this is, it's very much about indigenous techniques and tradition of crafts that are being documented here. But I think a lot of that, what is said here, would also be very applicable to endangered crafts and techniques that are disappearing, also in our museum objects, etc., that we do not know anymore how these were made. So there's a huge world out there which we can tap into to to document and to preserve also that kind of data. This image comes from Joe's presentation, but it is very much a very sort of clear-cut, simple structure on how our research takes place and what kind of questions we ask, and then hopefully the databases that are databases being built can help us with that. And search tools are hugely important, how they are developed and how they are tuned in on that kind of questions that we have. In the Rijksmuseum, and this is a wish on my wish list, we have a fantastic resource of 1,200 art technological books, manuals and manuscripts, which all discuss art technology. It's very unique to have so many together, and every month still new are added to it. This is only a few of them are digitized, and in an ideal world, this would be something to digitize and make available, but with annotations, with connections to objects, in a more inventive way, because that clarifies very much what is in these books. And an example is, for example, in one of the latest acquisitions is this book for the carpenter, which has all these key models in it, the keys you use for furniture, closed doors and things like that. The Rijksmuseum owns a huge collection of keys that is not necessarily studied that much. But here you have a wonderful connection between the object and the text, which we could make. It also has these automatons in it, very weird, peculiar kind of machines. We don't have any of those, but that would be a wonderful thing to try through crowdsourcing or citizen science to see if there are any of these around. Many interesting contraptions. I'm afraid I can't go into that, but it is very tempting to show you more. How do we work with data? And I just show you a few techniques where our research is used and informs databases, but also uses them. So this is dendrochronology, and I don't know how familiar you are with the technique, but it is a method of measuring the yearings in woods, especially the distances between them, which are representative for a hot summer, or a wet summer, a cold winter, etc., that the tree grows in a different speed. Those yearings can then be registered, and the distances between them, and compared to reference databases that exist from certain areas, not from everywhere. So there is a limitation to which kind of woods can be used with this method. There is a network in Europe which collects all these references with trees that we have a very secure sequence of yearings of. So if you then examine, for example, a panel, and this is work from Marta Dominguez Delmas, a dendrochronologist who at the moment works at the University of Amsterdam and works with us as well. This is a very big panel. This is the back, and you see how many planks there are. It's usually more than, in this case, quite 6, but she measured these 4. I'm only showing you one of the sequences of the plank 1 and plank 3, and as you can see that they match quite nicely. That is set against a reference, and the reference will tell you where the plank comes from, but also how old it is, when the tree was felled, and so on. It's a very, quite a precise technique, depending on, of course, how many yearings you have. It also is very interesting if these dendrochronologists, they collect this and they set it, they put it in a database. From each object goes in a database. And when they do a new measurement, they set that against the database and get references back with objects that were made from planks from the same tree. And in some cases, it means that The planks used for this Flemish painting correspond with planks boards used in a piece of furniture, which is now in a British collection, and so on. It can be quite varied, and it shows you also trade routes and where these boards ended up, because most of this is Baltic oak from Gdansk and that area, and it's very informative, more than just about the painting, to have these data sets, and then you can plot things and compare. There is a database being built on reports made by Peter Klein, a dendrochronologist who still worked with a magnifier, not with the high-resolution camera you just saw. He started this technique to date panel paintings, and he did more than 7,000 reports, which are all going to be in a database made by CATS, Center for Conservation and Art Technological Studies in Copenhagen, and the RKD in The Hague. And soon it will be available online. But the new approach with a high-resolution camera and the computer software, those reports are going to be added to that source as well. Another project that we are running at the moment is Impact for Art, which is CT for Art, from images to patterns, and it's a collaboration between CWI, the Center for Mathematics and IT, and the Rijksmuseum. And it scans with CT objects in a way that you can get very quantitative data. So it goes a lot further than just a 3D laser scan. And the surface can be very well documented in great detail. Just show you an example of one of the projects that's being done by the postdoc, Semila Sero. And she works with our conservator of ceramics, glass and stone, Isabelle Garrechon, on little sculptures. They're quite small little models, but they have fingerprints in the clay in many places. So her research concerns to document these fingerprints and create a database, because we have quite a lot of these fragments to see if they correspond between each other, if the same person worked on it. It's a very ambitious project, and Isabel's also making reproductions with her own fingerprints on it to use as a model. And the whole project from that Impact for Art is a very interdisciplinary collaboration directly with these data scientists and mathematicians. So we try to find communal language and to really get that collaboration going and really get a lot out of it. So here you see basically the trajectory of these things, of using the scans, 3D reconstructions, making these models, but also the interpretation of what you get out of that is quite an important part of the project. So in the fingerprints, she makes use of existing databases to train the computer. Then, of course, the big question is on how to apply that to these small clay models. It's a very exciting project, and I hope we can soon give you more results. However, there are unexpected encounters when you do this research on collections. There are always unusual objects in collections. So I'm going to tell you one unusual story, a curious history of the green soup turtle. And I think it's the right time of day at the end of the afternoon to have a story like that. The object, it started as an object that you see here. This painting was in the 80-Year War exhibition, high up on the wall. And the audience was constantly asking, what is it? Because this painting is painted on the shield of a green soup turtle. And it's not a small turtle, it's the carapace, as you call a shield like that, is 1.12 meters. So it's about this size. Here you see the inside, the ribs, and this is where some paint has been lost, and you see the quite beautiful colors and texture of tortoise, as you often also see it in other artworks. On it, the portrait is Prince Frederik Hendrik, Prince of Orange, a very important military figure in Dutch history. That's why this shield was in the exhibition. The question is, why on earth is this painted on a turtle? It's not an easy support. It's not a smooth painting support. So that's what triggered this research. Well, first of all, you mine any databases with images, 4 images from Prince Frederik Hendrik. This is a small selection, and you see he's often portrayed on a horse, with in the background the cities he freed from the Spanish, etc. And this is just coming from the Rijksmuseum, but there's a lot more of this material. So very useful to have access to all these images, Europeana, etc. All that has all fed into our research. And this seems to be quite a close comparison. So possibly this anonymous painting was made after a print. But of course we are not quite sure about that. When we started looking into it, it turned out we had 2 more turtles. And this one is, they're both slightly smaller, but this one is painted as well with a coat of arms from the Heren van Bennebroek. But the date, as you can see, is a big question mark. That's how it is catalogued. And the other one, date unknown, is not painted, but has quite curious sort of reinforcements of metal plates that is hammered in the right shape attached to it. Again, many questions. So we did a search to find out if there are more painted turtles. We only found so far one that is in Vienna, and it's supposedly Italian from the early 16th century, so quite a lot earlier. Interestingly, you have Frederik Hendrik, who was a military personality, man, very important, and here you have a battle scene as well. And this battle scene derives from Livy's History of Rome, the battle between the Romans and the Gauls. They have 8 more shields in Vienna, in a Kunsthistorische Museum. With this shield, they have hung them in the armory. So there is a connection here made already. And there's another story in this whole thing, and that is how were they caught and where, and what were they used for. You see an image that shows you how they were trying to catch them. Not an easy thing, clearly. There's a lot of this, a lot of images like this, and it makes a great story altogether. Another story is that these shields appear in a Kunstkammer, in cabinets of curiosities. So this one simple shield has so many connections to be made, which all lead to different data sets and information. And of course, this connection with the military also is interesting, because here you see, and this is one of the best images I found of this. This is the movement described by Livy, where the tortoise is the soldiers holding their shields above their heads or on the side, and they are protected and they move slowly forwards. But if it all goes wrong, then the movement is known as the hare, because they all run away, as you can see here in this Asterix and Obelix. But this is, although this is a very nice illustration, but it is actually a clear connection to why you would paint something military or a battle scene, maybe, on a tortoise shield. However, wanting to know more, we wanted to know, where does this thing come from? And I got in touch with marine biologists in Exeter University who specialize in this field, and they are now, and I had to sample the turtle for them, which was much more difficult than sampling a painting, I can tell you that. They are now going to analyze the DNA. They're very excited, this 400-year-old DNA. to see where this turtle comes from, because it's the kind that is Chelonia midas. It's around in lots of places, but DNA can pinpoint much better exactly where this one lived, which will, and here you see how they work with all these plotting where these populations come from, and the frequency that they are there, etc. And knowing where this turtle comes from, and the other two, we're sampling them as well, will inform the trade routes again, because they're not living in the Netherlands. They would probably come from the South Americas, which of course at that time was on the trade route. And but we want to know exactly where. And they were taken in the ships as food. And the shields, of course, turned out to be quite valuable. So the shields were kept, but the turtle will give you about 200 kilos of meat, and they would eat them when they run out of their regular supplies. So getting into this kind of object, and suddenly you are in all kinds of very unknown territory, that databases from different disciplines. And you work with all these different people to understand. I've been in touch with taxidermists. How do you prepare a turtle shield? And so on, history of science. And today, the green turtle is an endangered species. So in the States, you're not allowed to catch them or eat them, because then you get a big fine, which is quite substantial. So this preparation of tortoise soup is no longer possible. This kind of biological material is getting much interest right now, and there's a new project that just started that hopefully we can contribute to. I've only just heard about this week. It only just started. Arc hives, and it's about bees, and it is based on finding pollen and other traces of bees in wax, and they are in need of ancient beeswax, which you can find in seals, for example, on the back of paintings or other documents, and even in wax linings on paintings, which are sometimes from the late 19th century. So that's a very interesting project, and with a lot of people interested, and they are looking for more material and more connections. So you're very welcome to ask me where to get contacts for this. And to finish, a project that is running for a year now about glass in paint. So many artists and painters in the 16th and 17th century would add glass to paint layers. Usually we think it's said it is because it dries the paint quicker, or bulk material, but we thought there would be more to it. So this is a Nikos project with a whole team of scientists and all kinds of interesting people, glassmakers, and so on. One of the things we look at in that project is the use of a pigment called smalt, which is a cobalt-colored glass. And here you see the color. This is a Maarten de Vos painting, 1581, and you see a beautiful blue. This is unusual because smalt is, in most of the cases, totally discolored. So here you have a cross-section. This is a very tiny little sample that's taken from the painting and embedded in resin and then polished at a 90-degree angle, so you get the layers of the painting. And this blue, as you can see, this beautiful blue, this is also smalt. This is a UV image that shows you the particles better than a visible light image. But here you see it has lost most of its color. That's unusual because you expect the top layer exposed to light to lose the color and not necessarily this. So are there more than one quality of smalt? And you find that in the price lists. This opened up a whole piece of research again, where we look into the paintings, of course, but also in enamels, where smalt cobalt blue is used everywhere. Fake sapphires, recipes for that are in all the sources. And this is a reconstructed piece which shows it's beautiful. You could easily say this is a sapphire. Glass, painted glass, and so-called glass cakes. This is a fragment of a round a piece which is very dense in color and stamped by the firm that made it in Venice. And you would take a little piece, add it to colorless glass to color the glass, or you would grind it and use it for the enamel. We think they might also have ground it and use it in paintings. So there's all these connections and cross-disciplinary elements that we are looking into. And even reconstructions were made here in Portugal, so working with them. And here they try to make it, and you can see it is very nice and blue. Then they had to try to get it out of the crucible, and that didn't work. But they done another one, and that worked brilliantly. So adapting your methods, you will find the right way to do it. But the blue color is fantastic. So in this project, we are using also data science and databases. This is an image of almost all the cross-section images from the Rijksmuseum. We're near to 12,000 images here, both in UV light and in normal light, like the ones you just saw from the smalt. And here you see the blue corner, because this is sort of by Rob Erdmann, our data scientist, organized that the colors group together. So here you see more of the blue ones. However, what we want to do is create a search tool using segmentation that recognizes these glassy particles in paint layers, because they're very angular, they have a very clear morphology. So that's what we're working on together also with the CWI and Rob Erdmann. And it's, so that will create a way of searching this kind of databases. And hopefully these kind of databases will become bigger and bigger, joining with the National Gallery and other museums who have similar kind of material, and then more search tools like that can be built. That brings us to the final 2 minutes on the Night Watch, Operation Night Watch, and you're all invited to come up after this to have a look upstairs in the Gallery of Honor. This is a very big operation. As you can see, this is the research team. It's more than 25 people and growing. And this is totally interdisciplinary. So there's data scientists, there's art historians, curators, etc. And we are standing here inside the glass house, surrounding a happy director. And it's at the beginning of the research. So up till June next year, the research will be mainly focused on scientific analysis and imaging. And here you see the start with macro X-ray fluorescence, scanning the painting, and what the technique does, it sort of detects elements, lead, copper, cobalt, which connect to the pigments used. And that is the connection to my smalt project that comes into here as well. Here you see the painting. And we focus for a moment on this sleeve here that looks slightly odd, with lots of green highlights, but a lot of brown. Here you see some details with the stereo microscope, which we are actually doing a lot of now. And you can see wet and wet, and how that kind of paint, how he painted quite messily, mixing wet paints, etc. Here you see that sleeve, and then here we have a map that only shows in the light areas the presence of cobalt. And cobalt is, of course, the base of that smalt pigment. And here you see nickel, which is also part of that same smalt pigment. So it's clear that in all the dark areas, shadowing the green sleeve, we have the smalt. A smalt degrades often in oil and becomes very dark and brown. So it totally changes the contrast in an area like that. So smalt is part of this bigger project now, where we combine all these different techniques. We will be in the archives and so on, but we will generate lots and lots of data, collaborating with all these institutions on their smalt samples from their works. So there, we need you to help us build that kind of databases. Joe mentioned already the Arch Lab and that kind of structures. That sounds like the thing to do. But that is where, as a researcher, you have to be supported with this kind of initiatives to find a place for all these data. The Night Watch is going to be photographed in high resolution. And this is from the photographers who provided me with this slide. Here we see how they, in tiles, will photograph it. 42 tiles, 2.42 gigabyte each, using the scissor lifts and the platforms and a special kit to do that. But it goes up to the next stage, which will be more than 5,000 ppi per as a resolution. And if you then see a tile of this area and you zoom in with this kind of resolution, you can see the pigment particles, and you can, you get a fantastic documentation of the painting, its condition, which you then, if you do this again in 5 or 10 years' time, you might find changes, or, so there's a lot of information here that will be very valuable for the future as well as for present research. However, it will generate, here's another comparison. This is the stereo microscope, and this is the image with the Hasselblad used for that high resolution. The colors can be controlled. Here we have much more deformation in the image. So it's a real fantastic way of documenting this painting, and we can, as researchers, benefit from that. However, where do you put these enormous files? And that is something that our research services, led by Saskia, great collaboration. We need them to help us with sustainable storing these files, but also to find ways of opening them up for other researchers as well, which will be quite a challenge, I think, and especially if we think of the FAIR principles. So this was a little look into the material that we do. We do a lot more, but I hope it gives a bit of an insight in the variations from all these different objects, and how, as a user, you have to navigate that landscape of all the different data sets, databases, etc., and find a way to use them. And several people today said that, and Joe said that too, that a conversation with the users, with the art historians, conservators, scientists, etc., for what do they need is very important, depending very much, of course, on the data you have available. Thank you very much.